Well, good day, everyone. We are learning today about electrochem, and the place we start with electrochem is one of our old favorites. We want to start off with redox. So let's take a look at this. Consider the reaction of aqueous solutions of potassium dichromate with sodium iodide in an acidic solution. Write the balanced net ionic equation for this reaction. Ooh, mamma mia. Okay, so I have potassium dichromate with sodium iodide. Let's see if we can do that. So potassium chromate, I have K2CrO4, right? With sodium, these are solutions, so aqueous, right? Plus sodium iodide, aqueous. And you know what? I'm not sure what's going to happen here. We do have an idea. Whenever we see, dichromate, yoink, potassium dichromate, Cr2O7, there we go. Whenever I see dichromate, I think redox because dichromate is a very strong oxidizer. So let us talk about balancing redox. Or let's first, let me put it this way. Let's kind of go through a quick review of redox. Okay, so we have redox, right? So what is redox? Well, redox is really a reaction. Really, it is a what? Um, a reaction in which an oxidation, half reaction, and reduction, half reaction occur. Or another way to say that is what? This is a reaction in which oxidation, and reduction, they occur, right? Good. So I think that's a pretty good definition of redox. Now, underneath this, we kind of need to clarify some things about, hey, what is oxidation? Oxidation. Oxidation. What is oxidation? Well, this is a half reaction in which electrons are what? Well, I always remember the O. Electrons are lost. Good. So if we look at something like sodium, and it becomes sodium plus 1 electron, that represents oxidation. Now, another way to know what's going on, we can look at the oxidation states. The oxidation state of sodium here is 0. The oxidation state of sodium cation is +1. Whenever my oxidation number increases, then that is also oxidation. Now, we can also look at reduction then, right? What is reduction? Well, reduction is a half reaction in which electrons are what? In which electrons are gained. So I can take chlorine and add 1 electron to that, and I would get my chloride. In this case, I am adding electrons, so that would be reduction. Also, notice what's happening to my oxidation states. This goes from a 0 to a -1, so my oxidation state decreases. And this, I mean, if you ever get lost, here's the way I always look at it. This number is doing what? It is going down. It is decreasing and decreasing, or it is reducing. The number is reducing, meaning that must be reduction, and the opposite of that has to be oxidation. And what's important to remember is that these two must occur together. Where does this electron go? Well, this electron goes over here to the chlorine. The chlorine cannot reduce unless the sodium oxidizes, so I cannot have one of these half reactions occurring on its own. It's got to occur together. Good. So there we have our oxidation and reducing ideas. Now we can have something called what? We can have agents, and I can have oxidizing agents, and also known as oxidants. These are things which cause another reactant to oxidize. Okay, so these things cause another thing to oxidize. Something in them, some species in the oxidizing agent must do what? It must reduce. Something in the oxidizing agent is reducing. So look at what's reducing, and that's going to be part of your oxidizing agent. And then we can have what? A reducing agent, also known as a reductant, right? And that is something which, it's really not something, it's a reactant. It's a reactant which, and we should put that up here too, a reactant which causes another to reduce. And if it causes something else to reduce, that means something in my reductant must be oxidizing. Okay. Oops. Good. So I think that's my general overview of redox. Now, the question that we're asking has to do more with balancing redox. Oh, maybe I should add what are some common oxidizing agents, right? Dichromate is a very common oxidizing agent, and permanganate. You see these two guys listed right away, start thinking that that is redox, okay? Good. So let's talk about balancing redox, and I'm going to need a lot more space. Most of you guys remember this, but in case you have forgotten a little bit, when we balance redox, we need a little more than we had done, in normal balancing. So balancing redox, what we usually want to do is assign oxidation states, assign oxidation numbers to ID your oxidizing half reaction. And then for that, what are you going to do? You're going to balance your atoms except for oxygen, hydrogen, and then you're going to balance your oxygen by adding H2O, and then you're going to balance your hydrogen by adding H+, and then you're going to balance charge by adding electrons, right? Then we're going to do this whole thing for the reducing ID, your reducing species, your reducing half reaction, and we're going to do all of this again, like magic. There we go. And then what are we going to do? We need to make my electrons even in both. So we're going to find a lowest common multiple of electrons in both half reactions and multiply each to get to the least common multiple. And really what we're doing is we're recognizing that my electrons must be the same in each half reaction. And the only way you can do that is by multiplying, making the half reaction occur more times. And then what we're going to do, we're going to combine these two, and then 6 simplify. Simplify. There we go. You guys remember all of that? Great. So let's do this. Let's go back to my original question. Here I have my dichromate and my iodide, and we can start looking at my oxidation states. Now here's, you kind of have to do let me take a quick look up here. Okay, you kind of have to know a little bit about some of these things. So what did we say? I said my dichromate is an oxidizing agent. That means it's going to cause something else to oxidize. So what can oxidize? Can Na plus oxidize? Can Na plus go to Na2 plus? No, that's not going to happen. Can I minus go to I2? Yes, there we go. That's what's going to oxidize. So I have I minus going to I2. Now, what happens to my dichromate? You kind of just have to know that dichromate is going to go to chromium 3. So there you go. We have our two half reactions. This is a -1 going to a 0, so this is my oxidation half reaction. So this is going to have to be a reduction half reaction. Let's check it out. My chromium here is a plus what? Well, I have -2 times 7 is -14, and that has to equal -2, so that has to be a +12. So this means this is a +6. So I'm going from a +6 to a +3. Yes, indeed, that is reduction. All right, so let's start with my oxidizing half reaction. Let's follow the steps. So I have I minus going to I2. What's the first thing? We've written our half reaction. Now what do we want to do? We want to balance atoms. I have 2 iodines on the right, and so I have to put 2 iodines here. Are my oxygens balanced? Yes. Are my hydrogens balanced? Yes. Is my charge balanced? Well, right here I have 2 times -1, so that's a -2. Over here I have a 0, so I need to add 2 electrons. Notice, where are my electrons? They are on my product side, meaning they are lost. So when 2 iodides become iodine, you lose 2 electrons, and that is, you got it, oxidation. So now let's take a look at my a little more complicated dichromate going to chromium 3. Oops, chromium 3. First thing I want to do is balance my atoms. Notice I have 2 chromiums here, so I have to put a big old 2 right there. Great. Now I have 7 oxygens. I need to add 7 waters. Now I have 14 hydrogens, so I need to add 14 hydrogen cations. Now we need to balance this dog. Here I have +14. I need to balance charge. Here I have -2. So this whole thing is what? This whole thing is a +12. Over here I have a +6. So how do I make a +12 equals a +6? I need to add 6 electrons. Good. Now we want to seek that least common multiple. What's the least common multiple between 2 and 6? The answer is 6. So that means I need to multiply this by what now? 3. There we go. So I'm going to write it down below here. So 3 times 2 is, 3 times 2 is 6 iodides, yielding 3 I2s plus 6 electrons. And then what do? We want to combine. Yoink. Let's combine 6 electrons plus 14 H plus my dichromate plus 6 iodides yield 2 chromium 3s plus 7 waters plus 3 iodines plus 6 electrons. And then what do? We simplify. Electrons should always go, right? And is there anything else I can simplify? The answer is no. So let's check. How many hydrogens here? I have, let's put this in the middle. I have 14 hydrogens on the left. Good. How many on the right? 14, right? 7 times 2. Chromiums. I have 2 chromiums here. I have 2 chromiums there. Oxygens. I have 7 on the left and I have 7 on the right. And I's, right? I have 6 I's on the left, and 3 times 2 is 6 I's. And the last thing we need to balance is charge. Charge on the left is, what do I have here? 14 plus, oops, not 14 plus, 14 minus 2 minus 6. So that looks like what? That's 12, 6. Looks like a +6 on my left. And over here, what do I have going on? 2 times +3 is a +6. Woohoo! So that is my balanced reaction. Oops. 14H plus dichromate plus 6 iodines yield 2 chromium 3s plus 7 waters plus 3 iodines. And notice this said balance this in acidic solution. Is it acidic? Yes, I have those 14 H pluses, so that means that is balanced in acidic solution. Once again, what did we say is oxidizing? I is oxidizing. Cr is reducing. What is my oxidizing agent? Well, what is causing my iodine to oxidize? And my ox agent then would be a reactant in which something is reducing, and that would be my dichromate. So Cr2O7 2 minus is my ox agent. And then what is my reducing agent? My reducing agent would be my I minus is my reducing agent. And I guess if you wanted to be completely correct, and well, this is for the net ionic, right? Does it ask us for the net ionic? Oops, sorry. Yeah, we wanted to write a net ionic equation. Good. And so I think we've identified everything we need to for a net ionic. All right, good. You guys pause me and try this next one. Let me bring it up. You guys do this one and see me when you are done. Okay. Okay, so I hope you were able to do this. One of the key things you would have to know, of course, is permanganate. I said permanganate is a typical oxidizing agent. So what does permanganate reduce into? Permanganate typically goes to manganese 2. So if you didn't know that, that may have been a little difficult. Just to check out, what do we have here? I have minus 2 times 4, so this is a minus 8, and it has to be a minus 1. So my manganese is going from a plus 7 to a plus 2. That means my oxidation state is decreasing, it is reducing, so that means my manganese is reducing. If it's reducing, what can oxidize? Well, I have my iron 2. What is iron 2 going to oxidize to? Well, there's only one thing iron 2 can oxidize to, well, most common, right? Iron 3, so that means my iron is oxidizing. All right, now I think we can start off with our balancing, right? So we want to take my iron 2 going to iron 3, and let's balance atoms. Are my atoms balanced? Yes. Are my oxygens balanced? Yes. Are my hydrogens balanced? Yes. What do I have to balance? I have to balance charge. I'm going to add 1 electron. Notice the electron is on the product side, meaning the iron 2 is losing the electron, which is what we'd expect because oxidization means losing electrons, and that's exactly what's happened here. So that is our oxidation half reaction, right? So when I look at my reduction half reaction, I'm going to start with my manganese going to manganese 2. Great. Are my manganeses balanced? Yes. Are my oxygens balanced? No. I need to add 4 waters, and then I need to balance my hydrogens, so I have to add 8 hydrogen cations, and then I need to do what? This is a plus 8 and a minus 1, so that's a plus 7. Over here I have a plus 2, so I need to add 5 electrons. So I have 5 electrons here, and I have 1 electron here, so I have to multiply this by 5. That's my least common multiple, and now I'm going to add these two dogs together. 5 electrons plus 5 iron 2s plus 8 H pluses plus permanganate yields manganese 2 plus 4 waters plus what? 5 iron 3s plus 5 electrons. Good. And then let's reduce. I have 5 electrons on both sides. There's no water or hydrogen on both sides to reduce, so this is our balanced equation. Just in case, let's check our atoms. I've got 5 irons, and I have 5 irons. I have how many hydrogens? 8 hydrogens and 8 hydrogens, oxygens, for 4 oxygens and 4 oxygens, and manganeses, 1 and 1 in terms of my charge. What do I have? 5 times 2 is 10 plus 8 is 18, so it looks like I have a plus 17 on this side. Oh, that can't be right, can it? Well, let's find out. I have 5 times 3 is 15 plus 2. Hey, mamma mia, look at that. Charge of plus 17. Woohoo! Good. Now, let's go back. What is my oxidizing? What is oxidizing? We said what? Iron is oxidizing. So what is my oxidizing agent? What is causing it to oxidize? Well, my permanganate. What is reducing? Well, we said my manganese is reducing. And how do I know that? Remember, we look at oxidation states. My manganese went from plus 7 to plus 2, so it dropped, so it reduced, so manganese is reducing. What is my reducing agent? Well, it's what's causing my manganese to reduce. It's going to be my iron 2 is my reducing agent. Woohoo! Okay, let's see. What's next? All right, so now you're going to have to balance this thing in terms of basic solution. Now, here's the cool thing. To do this in basic, guess what? We do everything we do before, and all you have to do is change all of your hydronium to, excuse me, all of your H plus to water by adding hydroxide. And so here, let me show you an example. So let's take this guy here. And let's say that we wanted to balance this in terms of we wanted to balance this in basic instead of acidic. Right here, this is making this acidic. So how do I make this whole thing basic? Well, I'd add 8 hydroxides to both sides. Got it? So what would happen when I have 8 H pluses reacting with 8 hydroxides? What do I make? I make 8 waters. So this thing becomes 8 waters. And then what I do? Now I have 8 waters on this side and 4 waters on this side. That means I have 4 excess waters on this side. Yoink, yoink, and you're done. And notice over here I have floating what? 8 hydroxides. That means it is basic. Woohoo! Okay, let's do this first one together. All right, so I have, and this is a little bit different, right? I have manganese. I have permanganate going to manganese oxide. And I have cyanide going to, what is this? CNO minus. Okay, we're going to have to figure out. I'm not exactly sure what is oxidizing and reducing. I assume my manganese is reducing. Let's find out. My manganese here is a plus 7, right? Because I have negative 2 times 4 is negative 8, and it has to equal my negative 1. So that's a negative 7. And this is a negative 2, and I have 2 of them, so that's a negative 4. So this is a plus 4. So my manganese is going from plus 7 to plus 4. That looks like it's that number is going down. It's reducing. So that means my manganese is reducing, right? Which means either my carbon or nitrogen is going to have to oxidize. Well, in this case, my nitrogen is the most electronegative, so it's going to have a minus 3. And if the whole thing is a minus 2, that means my carbon has to be a plus 2. Over here, I have a minus 2 and a minus 3, which is a minus 5, and the whole thing has to equal a minus 1. So this is a plus 4. So that means my carbon is going from plus 2 to plus 4, which is oxidizing. Okay, there we go. So let us work this. So I have my C, my N minus going to CNO minus. Are my atoms balanced? Yes. Now I want to add 1 water on this side, which means I want to add what? 2 H pluses on this side. Which means I need to add 2 electrons on this side, right? Because I have a minus 1 here and a minus 1 and a plus 2, so that has to be a minus 2. And notice my electrons on my product side, so indeed it is oxidizing. And then let's look at my permanganate, MnO4 minus going to MnO2. My manganeses are balanced. It looks to me I need to add 2 waters here, which means I have to add what? 4 H pluses. And what do I have over here? I have a -1 and a +4, so I need I think 3 electrons. Let's make sure this is a +4 and this is a -1, and so it's a +3, and I have no charge on the right, so that's a -3. Good. So what do I have to do now? I have to multiply this one. My least common multiple is what? Between 2 and 3 is 6. So I have to multiply this by 3. And I have to multiply this by 2. And combine those two. Here we go. Good. So I have 3 waters plus 3 cyanides yield 3 CnO minus plus 6 H plus 6 electrons. And below that, I have 6 electrons plus 8 H pluses. And you got to be careful here so you don't make any mistakes on your multiplying or forgetting to multiply. Like, ooh, I almost did there. Plus 4 waters, right? So let's see, 6, 8, 2, 2, 4. And then what are we going to do? We're going to combine these and eliminate. So I have 6 electrons plus 8 H pluses plus 2 permanganates plus 3 waters plus 3 cyanides yield 3 CnOs plus 6 H plus 6 electrons plus 2 MnO2s plus 4 waters. And now we want to simplify. 6 electrons, 6 electrons. Good. What else can simplify? I have 8 hydrogens on this side, and I have 6 on this side, so those go, and I have 2 hydrogens here. I have 3 waters here, and I have 4 waters here, so those guys go, and that's left with just plus 1 water. Good. And that would be great were I balancing in acidic, but I am not. I'm balancing this in basic, so I have to add 2 hydroxides to both sides, which now turns this into what? 2 waters. Good. And I have 1 water over here, so what happens? That cancels, and this water becomes 1 water, and now I can write up the whole thing. So I have water plus 2 permanganates plus 3 Cn minus yield 3 CnO minus plus 2 MnO2s plus 2 hydroxides. All right, H's. How many H's do I have? It looks like I have 2 over there, and I have 2 here. O's. I have 1 and 9. I have 9 O's on the left, and I have 3, 7, 8, and 9 O's. Good. It's looking like I'm doing pretty well. Manganeses. I have 2 manganeses and 2 manganeses. Good. Not 2 manganeses. Carbons. I have 3 carbons, 3 carbons. Nitrogens. I have 3 nitrogens, 3 nitrogens. In charge, I have a -2 and a -3 is a -5, right? I have a -3 and 2 -1s, a -5. Woohoo! That is the correct answer. All right. Pretty easy. You guys do this one, and I'll bring you back. Well, I hope you didn't find this too difficult. Let's take a look at what's happening here. I have my aluminum going to, what is that? It looks like tetrahydroxoaluminate. Oh my gosh. Did I just say that was a complex? Now, hey, maybe I have a complex. Good. So my aluminum, I have 0 here, right? And my aluminum here would have to be a +3. So my aluminum is oxidizing. Good. And what's my other option? That means I have NO2 minus going to ammonia. Right here, my N is a +3, and over here, my N looks like a -3. So my nitrogen is reducing. Good. So let's work on balancing these dogs. So I have aluminum going to tetrahydroxoaluminate. And my aluminums are balanced, yes. My oxygens, I have 4 oxygens on the right, so I need to add 4 waters on the left. Now I have what? Looks like I have 8 hydrogens here, and I have 4 here, so I need to have 4 H pluses. And I have a charge of a -1 and a +4, so I need 3 electrons added there. And then I have NO2 minus going to my ammonia. My nitrogens are balanced. I need to add 2 waters on this side, so I have my 2 oxygens. Now be careful. How many hydrogens do I have on my right? I actually have 3 from my ammonia and 2 times my water, so it looks like +7 hydrogen cations. And now to balance that, I have a +7 and a -1, so I need 6 electrons. Whoo, mamma mia. At least I have a simple least common multiple of 6. So I multiply this top by 2, right? So that I would end up with 6 electrons. So I'd have what? 2 times 4 is 8 waters plus 2 aluminums yield 2 tetrahydroxoaluminates plus 8 hydrogen cations plus 6 electrons. Hey, let us reduce and simplify. So I got or let us combine and simplify. 6 plus 7 H plus NO2 minus plus 8 waters plus 2 aluminums yields ammonia plus 2 H2O plus 2AlOH4 minus plus H plus, H plus 6 electrons. Now let us simplify. 6 electrons go, 6 electrons go. I have 7 hydrogens on this side, I have 8 on this side, so that means these guys are all gone, and only one of these guys remains, 1 H plus. How about my waters? I have 2 waters here, and I have 8 waters here. That means all of these go, and I end up with only 6 waters on this side. Got it? Good. And that would be fine if we were balancing in the acid. But I have to get rid of this H plus, and I'm going to do that by adding a hydroxide to both sides, right? And so this thing becomes what? This thing becomes 1 H2O. Good. And I have 6 H2Os over here, so this 1 H2O is eliminated, and the 6 becomes 5 H2Os. Woo, mama. Okay, let's now put this all together. NO2 minus plus OH minus plus 5 waters plus 2 aluminums equal ammonia plus 2AlOH4 minus, and I think that's it, right? Because everything over there has been eliminated. Let us check. A nitrogen, I have 1 on the left, 1 on the right. Oxygens, I have 2, 3, and 5. Looks like I have 8 oxygens. And what do I have here? I have 4 times 1 times 2 is 8 oxygens. H's, I have 1 and 10, so that looks like 11 H's. Over here I have 4 times 1 times 2 is 8 plus 3, 11 hydrogens. Aluminums, 2 and 2, and our big checker charge. Over here I have -1, -2, I have a -2, and over here I have 2 times a -1, so -2. That balances. And notice it is basic. All right, I hope that helped. I will catch you all next time.